Astronomers have discovered for the first time that rocky exoplanets can hold large amounts of water from the moment they form, a new study has revealed. Life is found almost everywhere there is water on Earth. As such, searches for potentially habitable exoplanets were mainly focused on the existence of water. Previous research suggested that the new planet would have obtained large amounts of water from numerous asteroids that bombed the surface of the young planet shortly after it was formed. Now scientists have found evidence that water can be one of the earliest components of a rocky planet. James Webb detects water vapor in rock planet formation zone. Life on Earth has been born with miracles and miracles. In particular, water, which is an essential element for life, reached Earth at the right time, so life could be born on Earth. However, how water reached Earth and whether a series of similar processes could reach a rocky exoplanet orbiting a star in a distant orbit are still veiled. And James Webb announced a new discovery in the PDS 70 planetary system, located 370 light-years away, that could solve the mystery. The parent planet PDS 70 of the above planetary system has an internal disk and an external disk made up of gas and dust, and the two disks have been found to be separated at intervals of about 8 billion kilometers. And it is known that there are two giant gas planets in the upper gap. New observations by the James Webb Space Telescope MIRI have detected water vapor in the system's internal disk, a distance of about 160 million kilometers from the star. Due to the K-class parent star, which is colder than our Sun, there is a slight temperature difference, but recalling that the Earth orbits 150 million kilometers from the Sun, this area is where a rocky terrestrial planet can be formed. PDS 70 is a star similar to our Sun. By observing it, we can track how planets in our solar system were formed, and what the chemical composition was before they were fully formed, said Giulia Perotti, the study's author, who only reveals younger and lower temperatures. He is an astrophysicist at the Max Planck Institute of Astronomy in Heidelberg, Germany. Dr. Giulia Perotti of Heidelberg MPIA in Germany, who led the study, said, "Water has been found on other disks, but planets are now being built. And it is the first time that water has been found in an area so close to the star," emphasizing that this type of observation was not possible before James Webb. It is also the first time that water has been found in a region where rock formation is possible within a planetary disk where more than one primitive planet already exists. Using NASA's James Webb Telescope's mid-infrared spectroscope MIRI, scientists discovered hot steam-like water at about 330 degrees Celsius near the center of the gas and dust disks that form the planet surrounding PDS 70. Prof of MPIA, co-author of the paper, Thomas Henning added, "This discovery is very interesting in that it examines areas where Earth-like rock planets are generally formed." Professor Henning is the co-director of MIRI, a medium-infrared observation tool, and the head of the MINDS team that analyzed data. Not only water vapor but also relatively large amounts of small dust grains were found. PDS 70 is estimated to be about 5.4 million years old. Among the stars with disk-forming planets, it is a relatively old star, so the discovery of water vapor was not expected much. Over time, the gas and dust content of the disk surrounding the solar system decreases, as the parent radiation and solar wind blow away these substances or the dust grows into larger and larger solids, eventually forming a tail or planet. This is because astronomers did not find water in the center of the disk of a similar age in previous studies. It has been suspected that water cannot withstand the harsh radiation of the Sun, which could turn rocky planets into dry conditions. One possible explanation for the existence of this water is what is left of the water-rich nebula that gave birth to the PDS 70 system. Dust and other materials in the planet formation zone could potentially protect the water from star-destructive radiation, researchers explain. Another possibility may have formed water vapor by combining oxygen and hydrogen gas entering the outer rim of the PDS 70 disk. This water vapor can drift closer to the star again. Astronomers have yet to discover a planet forming in the internal disk of PDS 70. However, the observation team found dust in the form of silicate, a raw material for rock formation. Professor from the University of Radboud in the Netherlands who participated in the study together. Rens Waters also explained that he found relatively large amounts of small particles of dust, so he not only detected water vapor but also made very interesting observations of internal disks. Taken together, the discovery of water vapor from this observation suggests that rocky planets can evolve with water from the beginning if they are forming in internal disks. Where did the water come from? The above remarkable observations raise the question of where the water came from. The MINDS research team presents two scenarios to illustrate this discovery. The first hypothesis is a scenario in which hydrogen and oxygen atoms combine to form water molecules, and James Webb detects them as they are. On the other hand, the second possibility is the hypothesis that ice-coated dust particles are transported from cold outer disks to hot inner disks, resulting in water and ice sublimation turning into water vapor. The dust must pass through a large gap neatly carved by two giant planets, so if the second scenario is actually possible, it is an observation that could be evidence of a very surprising water-carrying system that astronomers have only imagined to date. In addition, the above observations raise the question of how water can survive close to the star when the star's ultraviolet rays need to break down water molecules. Astronomers argue that surrounding materials such as dust and other water molecules are likely to have served as protective films, and as a result, it is predicted that water detected from the internal disk of the PDS 70 will be able to survive these harsh environments. The study of water mechanisms initiated by James Webb is only beginning. There are many things to observe in the future. Ultimately, the team plans to observe additional PDS 70 systems using James Webb's two equipment, NIRCam and IRSpec, in order to obtain more evidence to explain many questions.